Today we also have lined up some exciting sessions for you. So sit back and soak in the learnings, and we also have lots of interesting booths in order one. So we'd like to encourage you to please visit all of them during the breaks whenever you can. The engineering sector is growing exponentially, as all of you know, with a lot more focus on collaborative innovation to build sustainable solutions for a better future. And to celebrate the growth of success of the ecosystem, NASSCOM brings together the engineering research and design landscape at this summit. I'd like to introduce our speakers this morning and request the speakers to please come up on stage as I invite them, and request you to please give them a big round of applause as we welcome them. Please welcome on stage Kalapa Patara. Dr. Kalapa Patara is a leader, research and technology, Boeing India. Prior to Boeing, he has worked at General Motors and Pratt & Whitney in USA and Maruti Udyog. He has a PhD from the Pennsylvania State University, USA, and a bachelor's degree in mechanical engineering from IIT Kanpur. I'd like to invite on stage Uma Maheshwar, D, Chief Consulting Engineer, GE Aviation for 500 plus members, GE Aviation India engineering team at Bangalore. Prior to GE, Uma held positions with Larsen & Toubro for 8 years. I'd also like to invite on stage Shashikaran Anand, Director, Engineering, Collins Aerospace. Leading a team of 500 engineers, he has been with Collins for the last 14 years and leading 2 business units in the aerospace interiors and mission systems sector. I'd also like to invite onto the stage George Koipile, Engineering Chief, Honeywell. He spent 7 years working on light combat aircraft, the LCA, before joining Honeywell. He has been with the firm for 2 decades now. And moderating the session is Srinivasan Dwaraknath, Strategic Consultant, Aerospace and Aviation, with strong technical and management background combined with international exposure working across Europe, Asia-Pacific, and the Middle East and Americas. He has experience in managing teams across different cultures. He's a strategic consultant in aerospace and the aviation domain and works with firms all over the world. Request you all to please give them a big round of applause as we welcome them to this morning session. And I'd like to hand over the mic to Srinivasan.
Thank you for your kind introduction. We have a wonderful topic for our panel discussion this morning. It's designing a sustainable and connected future for aerospace. Probably will be more focusing on the sustainable part, of the topic. So, aviation industry, has taken a commitment to achieve net zero by 2050. All right. So, transitioning aviation to achieve this requires, complex, costly, and sometimes immature technologies, as well as direct collaboration across the value chain, whether we are talking about aircraft OEMs or whether it is airports, ATC, suppliers, and more importantly, investors and the governments as well. Okay, so how do we propose, to achieve this in the context of aviation? The first step being looked at is in-sector reduction of emission, across the industry, and that should contribute between 85 to 95%. And do carbon dioxide removal that's for the remaining emissions that cannot be reduced by in-sector means. So this carbon dioxide emission would act as a gap filler until the in-sector innovations kick in. That'll be the one. So that's the target, and that's the plan to achieve. So there's been a lot of debate on this, and is achieving a net zero by 2050 in aviation, is that a mission impossible, or can we really achieve that? So several groups have really weighed in on that, whether it is the IATA, ICAO, European Union, Americans, including our Ministry of Civil Aviation on the DGCA side as well. Recently, I saw a report a couple of months back by McKinsey, I think in July, titled "Making Net Zero Aviation Possible." They had interestingly highlighted 5 main levers in aviation to achieve the net zero emission possible. The levers are, first, reducing our travel demand. That's easier said than done, and that's probably difficult. Efficiency improvements, that's the main focus, including technological innovations in terms of operations, flight operations, design and manufacture of the aircraft as well. We'll hear more about it from our panel speakers today on that. Use of sustainable aviation fuel. Sustainable aviation fuel is going to contribute significantly over the next 30 years, more so in the initial part, And the expectation is that that will contribute about 65% of the emission reductions over the next 30 years. So that's going to be an important part of the overall plan. Then novel propulsion methods. We talk about electric, talk about hybrid, hydrogen, God forbid, nuclear in the future. You never know. So the different propulsion methodologies as well. And last but not least is the carbon dioxide removal as well. So with that, what I would do is that I will straight away kick in by starting my first question, maybe to you, Kalapa. We talk a lot about eco-innovations, okay, eco-innovation principles across the product life cycle of the aircraft. And how do you see that supporting the sustainability goals, and how that actually goes towards achieving the net zero targets we have?
First of all, thank you very much, and it's a pleasure to be on such a distinguished panel, and thanks everyone for joining. This is an exciting time and an exciting topic. And how much time do I have?
You have 3 minutes.
So yeah, let's start a little bit about where we are and what we are committed to. So the aviation industry, actually civil aviation, contributes about 2% of the greenhouse gases. That's the good news. The bad news is that has doubled in the last 10 years. It may have stayed at that percentage or a little more. And if you look at India's context, today we have about 600 airplanes, and that's supposed to get to over 1,000, counting the orders that are already there, and then to 2,000 in about 15 years. So we have to do something to control it. And then, we at Boeing, we do think that we also have a responsibility to help out the people who travel on the roads, because that's a leading pollution causer. So we are also looking at urban air mobility. For example, we have partnered and invested in a company called Whisk, which is going to make electric airplanes and make them fly. And those will be automated. So that makes it easy for people to actually get into those. It's not piloted. By 2030, we are supposed to come out with that. We've committed that all our factories, so we divide it into designing the aircraft, manufacturing the aircraft and maintaining it, and using it. We divide our sustainability into 3 areas. And this electric aircraft is a classic example of combining all of those and making it available to everybody. So if it's not piloted, everybody can fly in it, and that takes the pressure off the road and reduces the road pollution. If you go to the opposite end of the spectrum, we are working with the SAF manufacturers to improve their production. We've committed to make all our aircraft SAF compatible in short order. We have committed to make all our plants, factories, zero net emission, and the average factory is coming close to that. We have a few programs, some with GE, of course, on hydrogen-related things, some with electric aircraft. So there are 3 key technologies in propulsion. One is SAF, has its challenges. If everybody took SAF, then the crop pattern would change and we would be in trouble. Electric has the famous range challenge, and hydrogen is 18% more by volume required, so you need a bigger aircraft to store that, and that feeds into the aerodynamic drag and all those things. So we are focused a lot on designing the aircraft and planning its use, its flight, in a way that whatever aviation fuel comes in the future from our engine manufacturers, and they're all here, our aircraft can fly the furthest using that. So that will reduce the battery range problem, that will reduce the hydrogen carrying problem, that will reduce the amount of SAF use. If the aircraft is inherently built more fuel efficient and operated in a much more fuel efficient manner, we may not have to solve the battery range problem all the way. We may not have to cut down the crop pattern SAF. We may not have to store that much hydrogen. So that's the current focus of making a lighter, more aerodynamic aircraft. Of course, manufacturing it in a very environment-friendly manner. So everything from our coatings to paints to composite manufacturing, that needs to be energy efficient and minimizing pollution, and we do a lot of work on that, especially paints and coatings, to make them environment friendly. And finally, working with our regulators to fly the aircraft. The promise of aerospace was it will go point to point. Okay? Minimize the time you take and minimize the fuel you consume. We are far from that promise. We don't fly point to point, we fly waypoint to waypoint, which is a big difference. So working in that area to make just the flying more efficient.
Okay,
Take a
thank
pause
you.
now.
Yeah, thank you, Philip. And Uma, would you like to weigh in on that same topic? And you have your.
Hi, good morning, everyone. I must really start with this statement that at this point of time, we are actually witnessing reimagination of entire aerospace industry. Why do I say so? Because whatever technologies and whatever the ecosystem that we built are going to transform looking at the sustainability goal. And the sustainability goal is actually very, very, very ambitious. Aviation is one of that industry which took a very, very challenging target. So when it comes to technology, in terms of eco-innovation, there are 4 key things which I want to touch. One, around 65% of emission reduction, if you have to target net zero by 2050, would come from just replacing the current jet fuel with sustainable aviation fuel. And there are many associated challenges which I will talk about later. The second thing is around 19% of the reductions would come from carbon trading. There are regulations around carbon trading, and that would force certain discipline in reducing emissions. But the most important thing is around 13 to 20% reductions would come from technology improvements, aircraft and the propulsion systems particularly. And then the remaining 3% would be from other aspects. But when it comes to technology, let me focus on this. Again, there are 4 things that which are possible, and I must tell you that in GE Aviation, we are actually reinventing the future propulsion systems. The first is sustainable aviation fuel. It looks so simple. Can we just simply replace the current fuel with sustainable aviation fuel, and what would happen to the engines in the long term, the durability and those things. The second thing is around using hydrogen as a fuel. It looks again very good, but on paper, but when it comes to the technical challenges, burning hydrogen, storing, transportation of hydrogen has several technological challenges. Just put it in context, you need 10 times more storage space for hydrogen as compared to the current jet fuel. So which means you need to have a wider, bigger aircraft, and hence, the aircraft would change. The propulsion systems would change. But, net, it would, produce water vapor, which is great. So that's around using hydrogen. The third technology is around using electrification. Can we use batteries? And it has its own challenges, but we see some sweet spot in certain range of aircraft where we would use a combination of both the current propulsion systems and also the battery. Okay, so that's the fourth one. And the most important thing is we have launched a new program called RISE. It stands for Revolutionary Innovations for Sustainable Engines. We are targeting around 20% reduction from the current baseline. And again, if you look at the current propulsion technology, we have taken out every ounce of the opportunity from the current design. So we need to invent a future propulsion system which is very different from the current engine technology, which has matured over the last 70 years. So you name it, any kind of technology which is possible, we have actually accounted for, and that would give us around 20% reduction. And then there is, digital play and, manufacturing, which I will also cover later. But if you really talk in summary, we are at the cusp of this reimagination of the flight. The aircraft would look different, the engines would look different, the whole ecosystem would different. And, we are also facing a challenge of, currently aviation is coming back to the pre-COVID level. So we have to make the flight more affordable, at the same time more sustainable. At the same point, we have to look at radical innovations, and which needs a huge amount of funding and research. So we are really at both challenging and, very, very exciting times ahead. And I think it will present huge opportunities for countries like us.
Thank you, Uma. And Sushi, would you like to briefly comment on that as well?
Yeah. So good morning, all. I agree with all of you that sustenance is going to be a very critical thing. Not only in the aerospace but across the different aspects of life. At Collins, we are really placed well, and we roughly spend about $3 billion every year on developing the new technology And quite recently, I have seen most of these technologies are going to be, helping sustainability in the aerospace world. And currently, we are mainly focusing on three things. One is the connected aircraft, which also includes a lot of, airports, passenger service systems, etc., etc. This also includes flight, optimization, the path optimization, which we believe could save anywhere from 2 to 3% minimum fuel burn there. The next interesting thing is on the electrification. So again, electrification is divided into two groups. One is more like on the actuation systems, etc., which we believe could give us 3% of fuel burn reduction. Second one is on the hybrid motor. So probably I'm going to talk more on that. We at Collins are really working on cutting edge technology on electrifications and other things. So that's the second one. Third one is on the advanced material, right? So one of the tasks given to us was to make sure aircraft is going to give more mileage, right? Like the way we look at the mileage for the bike or car or something like that. So we need to make aircraft more lighter. So our team here in Bengaluru is working on a lot of technology projects, and I'm very happy to say that Collins Aerospace Bengaluru has produced hundreds of patents from our own team in Bengaluru, and we have couple of thousands of invention disclosure. We encourage every engineer in Collins Aerospace Bangalore to work on these cutting edge technology. So in nutshell, I believe the future the leaders are going to be one who masters the technology in sustainability, and who is going to meet all the requirement on this, both from the industry perspective as well as government regulation perspective.
That's a good point and a good note where you finished on the government regulations part, right? So, Uma, when we were discussing earlier, you talked about government regulations, and Kalapa, you talk with the Indian government as well and outside. Briefly, could you weigh in on that? How would this government regulations really, help sustainability?
No, absolutely. Government has a huge role to play. Just if you look at this sustainable aviation fuel, there's a prediction that it needs around $1.5 trillion of investment if you have to replace. This is the most easiest one. The current engines can just simply use instead of jet fuel, the sustainable aviation fuel. But how do we produce? We need land, it comes from all kinds of waste. You need the ecosystem, and you need plants, and we need also very sustainable way of manufacturing sustainable aviation fuel. Some of the plants which produce these fuels are the most pollutant, industries. So we can't afford to have. So we need to produce. We need to also supply economically. Today it costs around 3 times. So if you ask airlines to replace the current fuel with sustainable aviation fuel, it's simply not effective because it's 3 times more expensive. So to bring down the cost, government has a huge role to play, whether it in terms of policy, advocacy, or whether really investing, and a lot of private participation, and also research. How can we really bring the cost to an affordable level, right? And in terms of governments, there is a variation across the countries. If you look at Europe, they have this CORSIA, the carbon trading, very strictly enforced norm. And in India, different countries have the different approaches, but overall, aviation industry has signed for net zero. Some of the airlines have taken target of 10% use of SAF for all their flights by 2030. It looks very simple, but 10%, can you get 10% of uninterrupted fuel, again at a cost which is economical, so that they can compete? Airline industry is very, very competitive. So if the cost of travel goes up because of fuel, then the airlines are going to go through real challenges. So we need to make sure that the airline industry is sustainable, in terms of operations. At the same time, we need to achieve the goals.
Already in India, the fuel costs and the taxes are so high. If this increases, that could be. I mean, today, how much of SAF is used? About 2%? Globally,
Yeah.
Less than 2%, right? So it's being used. In terms of the government norms itself, what are the things you see government is actually implementing, Kalapa?
Yeah, I think I would put it this way, that governments need to step up, our government needs to step up in just bunny trailing on what Uma said. They need to invest in this research and they need to put in various pockets. We don't know the future. Yes, SAF is the immediate answer probably, but is it electric, is it hydrogen? If it's hydrogen, then government does need to at least make some encouragement in research in producing green hydrogen, things like that. We are not in favor of subsidizing, but we are in favor of paying for research.
Yeah.
The other angle I want to bring in is the regulators. They have a big role to play, and Uma mentioned, I think, the digital technologies to use. Okay, now digital technologies will really improve the development cycle. There is that famous 10-year, 15 billion cost of developing a new aircraft. Digital technologies can halve both those. And what that does is, that can repeatedly help us upgrade the aircraft, make new things. And these digital technologies, the regulators need to understand and certify those. Okay? And the regulators in this space need to be far more digital savvy. That's one area, and that will help this. The other one is just the airspace. So if we can improve the airspace management, for example, we have very little dual use of airspace here. If we can, so military keeps a large percentage of Bangalore airspace. The taxiing, the takeoff, the flying of the aircraft in India can become, for our calculations, up to 20% more efficient if the airspace is dual use. Once you have a 20% more efficient airspace, the SAF requirement is 20% less.
Yeah.
Okay? So those are areas where regulators really need to focus in on how to make the airport itself, the operation in the airport of the aircraft, the takeoff, the landing, and the point-to-point flight most efficient. That's where regulators can really help, and we can help them.
Absolutely. Good point you made in terms of digitalization and how that can contribute, because sometimes it's not very obvious, how that is. And you guys work a lot, George, and in your company on digitalization, product as well as operations and other things. How is digitalization contributing to these sustainability goals?
Thanks, everyone. In general, so the context is major emission from the aircraft is CO2, right? It stays in the atmosphere for long. So some say a major part remains there for 1,000 years to get recycled by the environment. So there are techniques the panelists talked about. One is reduction in fuel consumption or use sustainable aviation fuel. So that's one way. The other way is bringing technology to fly the airplane very efficiently, so we can reduce the fuel consumption. So there are a lot of technologies that are emerging to cut down the fuel consumption by the aircraft. So for example, so today, the data that we could not get from the aircraft, so we are progressing very well in instrumenting the aircraft systems, getting the data out. So once the data is out, so we have now young brains, very efficient to do a lot of data analytics and then do wonders, right? So there is a lot of effort going in instrumenting the aircraft systems. That was earlier not possible. For example, can we put some sensors in the engine itself? It's not, we cannot think, right? So it has to withstand the temperature, vibration. How will it get energy? Can it harvest itself, the energy from the engine heat? Or can we have sensors that can stand off and then analyze the gas emissions? There are technologies we can think of, right? And now so I would talk about another one, say weather-related disruptions that affect the aircraft flying a lot. So the more you are in the air, you are burning more fuel, you are releasing greenhouse gases. So in general, the thumb rule is for every kilogram of, let's say, the fuel burnt, we produce 3 times the carbon dioxide. That's a thumb rule. So the trick is in bringing, keeping the aircraft less time in air. So we might have heard, we read a lot of news in the winter times. You see the aircrafts are put on hold above Delhi, and then the aircraft run out of fuel and then go and then land in Jaipur or diverted. So the weather-related disruptions, I'm just taking an example. There could be many such disruptions that lead to longer flight, aircraft more time in the air, releasing more such gases. Now today we are talking about connected technologies. So the bandwidth of the connectivity has tremendously increased, right? From kilobytes, we have gone to megabytes, now we'll be talking about gigabytes. So you can siphon the data out. So Honeywell makes radars, weather radars, that are now connected. So you can get now live data, the weather data from the aircraft that is flying across the globe, and then the aircraft following can better plan and reduce their time in air. So the technologies are changing, and there is a lot of need to bring more analytics and then instrumenting the systems, right? So we can do better in efficient fuel management and reducing the gases.
Oh, okay, thank you, John. I mean, you gave us a very good breadth of what can be done, with digitalization technology and how it can work as well. Maybe what I will do in the interest of time, switch to a topic. Maybe you could give an example. Maybe we'll start with you, Shashi. Give an example of an what you call an exciting project. What do you think would be a game changer in terms of sustainability either you or your company is working on? It'll be good to hear that from all of you as well. That'll give a good view to the audience.
Yeah, so at Collins, we are really banking on electric propulsion because that's the area where we are able to see a good, saving in the fuel. So we have tied up with a couple of, groups as well as agencies. First of all, I would like to say our sister concern, Pratt, we are working with them to go with a hybrid aircraft. So basically, we will have a fuel burning engine from Pratt, and we are going to put our motor there. This is being prototyped and worked in Canada, and pretty soon we are going to have this. So this is the first initiative what we are doing. We are also tied up with a couple of groups in the UK to go for full electric aircraft. So we believe probably in next 10 years we would be able to certify a fully electric aircraft which can potentially take 50 passengers for about 500 nautical miles, right? Like say for example, you would be able to fly from here to Chennai and Hyderabad and those kind of things. So that's what we are looking into. And with this UK company, we are working on developing an electric motor which is going to be more powerful. We have two stages there. The stage number one, probably by 2025, we would be replacing two of their smaller engines with the electric motor, and remaining two would be still powered by the regular fuel, and probably by 2030 the entire aircraft is going to be going all electric. So this is the second one. And third one, we also have tied up with NASA as well as University of Illinois to develop a more powerful electric motor. And currently the tests are going on, and what we are hearing from NASA is probably as of now this is the best motor available. So I think from Collins, these are all some of the very critical initiatives what we are taking into, and like the way we are seeing a lot of electric scooters and cars with the green number plate here. I believe in the next 10 years we would be able to see couple of at least the smaller aircraft which would be fully working by the electric motors.
So you guys are betting on hybrid and electric.
Yes.
That's in a shell.
Yeah.
Hope you will not paint the aircraft green. So, how about you, Umar? What's your in your company?
I am so proud to say that the future of the propulsion systems, we would have the Indian footprint, because around 30-40% of the entire design on the next generation propulsion systems is happening right here in our G India Technology Center, which is one of the largest R&D engineering center. What are those technologies? One, we have collaboration with the Airbus to come out with hydrogen propulsion aircraft. So our engineers are working, and I'm also happy to say that we are doing some very fundamental path-breaking research in collaboration with IIT Madras. And we have fantastic, very promising results to use, hydrogen as a potential fuel for future. Second, we talked about the hybrid electric propulsion. Again, we have collaboration. We have announced this during last Farnborough Air Show. We have collaboration with Boeing to come out with a very innovative, aircraft which is powered by hybrid electric propulsion. Again, our engineers are working here. on the entire, the electric system. The third is the future of the propulsion system, this RISE program that I talked, which is in collaboration with our partner Safran. It has around 300 technologies. Anything that you can reimagine, challenge the current Brayton cycle, reimagine the entire propulsion system, lot of that very fundamental path-breaking work is happening. And we have also collaboration with universities in India. And so I think that would be a dramatic game changer because we think that can incorporate SAF, it can incorporate electrification, anything around hybrid electric, and also hydrogen. So this is like a future propulsion system which can incorporate any of these potential or all of these technologies. And finally, I also want to say that, and again, we have collaboration with around 20 universities in India and also research institutes. So we not only just design these things, but we also come out with a prototype. We test in collaboration with NAL or IITs, and we also have 150 labs in our center. So we're trying to really come out with those innovative designs for the future. Finally, I want to also say that we underestimate the role of additive manufacturing. Okay, so absolutely. This can reimagine. You can reimagine the way you design. For example, 800 odd parts of one of the engine, we reduce it to 12 parts. And more fuel efficient, cheaper, lighter, everything that would help us in getting the sustainability goal. Reducing the amount of material, reducing the cost, and also come out with more fuel efficient design. So again, we have collaboration with...
so it's across the spectrum of the propulsion, and this, along with the supply chain, the value system you're doing. I think, you're absolutely right. Additive manufacturing is a key. Smart manufacturing, IoT, all of these things, combination with the digital ones, it's really contributing significantly. George, from your area,
So I'll quickly take now three areas. The first one is the propulsion. So like any other company, Honeywell also is into electrical propulsion, especially for the upcoming UAMs and UAVs, right? So there are a lot of products already made available. So we might have read in the news. The second part is working with next gen airspace initiatives, CESAR, right? So there, as I was talking about, there are a lot of initiatives that Honeywell has brought products that can reduce the emissions. So one example is the GPS-based landing system that can increase the capacity of the terminal, right? It can allow curved approaches, multiple approaches to the runways. It can manage many runways. It can enable many runways without the ILS requirements, right? So it can really increase the capacity of the airport, the terminal, and then reduce the time the aircraft is going to be in the space. So we are talking about next gen technologies like continuous descent approach. So you need not have to all the time throttle up and down and then burn a lot of fuel. So the last one I wanted to touch upon is the sensors. So these are all technologies we are not talking traditional technologies. But naturally, there are techniques that we can employ to reduce the fuel. So one example is the North Atlantic route. So there there is a stream of air. So there is a study that says if we had efficiently used that, would have saved 15% fuel. That's a big saving, right? So everybody is trying to take advantage of that. So all aircraft wants to fly that natural stream of tailwind. So today, for safety, they have to fly 8 hours, 10 hours over the ocean. There are no traditional land-based navigation system and communication system. They have to rely on GPS and inertial for long durations, right? So the separation is large. Now longitudinally we separate 10 minutes, laterally we reduce, separate them by a degree, and vertically by 1,000 feet. If we can shrink it, now there is talk of reducing vertical separation to 500 feet and then lateral maybe half a degree and then longitudinal by to 5 minutes. You need sensors that can give you reliable position, right? Then only you can bring them together. Right? So traditional thing is to rely on GPS, but you need to have another alternate, that is inertial. Inertial generally is 1 nautical mile per hour is what is used in the aircraft. So 10 hours is 10 nautical mile. That's what we are talking about, 60 nautical mile separation of 1 degree. So you need very expensive sensors. So Honeywell is working on alternate navigation sensors. So you can rely on the star tracking, or there are many techniques. Some of them are matured, flight tested, that is going to enable leveraging this natural way of taking the advantage of tailwind and reduce the fuel consumption and emission.
Sounds quite exciting. I think we should watch the birds a little bit more. No?
Yeah, exactly.
Coming to you, Kalapa, if you could.
Yeah, first, I wanted to echo what everybody said and what George just said. We need to come into today here before we go into the future. So we really in India need, at the larger airports, ground-based augmentation systems, which will just take so much of the pressure off the aircraft and make it so much more, no taxiing, no fog, no nothing. And then in the smaller airports, we probably need to use satellite-based augmentation systems. That'll just open it up. So echo all of that. At Boeing, first I mentioned about our all-electric autonomous vehicle we are making with Whisk, and a lot of that work is going on in India, and it'll increase only that work. So I'm proud to say that. What we're doing is we are taking the pressure off even the automotive industry by doing that. We're not competing with them. It'll reduce the congestion and it'll make it accessible to everybody. You don't need a pilot, like I mentioned. And you fly point to point. So from Electronic City to the airport, you'll get in 20 minutes as opposed to 3 hours. That's one thing on the smaller scale. On the civil and military side, we are looking at concepts of aircraft which will make it easier for whatever propulsion comes to get there faster. So for example, we are working on something called the transonic truss braced wing. So wings, if you make them bigger, then they will start fatiguing. So we're putting a truss there and making it stronger, making it foldable. All those things, what that does in lay terms is it'll increase the lift a lot, and the parasitic drag that comes out of the wing is very little. So if it increases the lift, it increases the lift to drag ratio, makes it much more fuel efficient. And if you have an infinite sized wing, then you're like flying in a space shuttle with no atmosphere. So if you can get that concept, you can probably understand. And that's a very exciting and probably a near-term thing more than a long-term. The other concept that we are working on, and it's been floating around for a while, is the blended wing body. That's something that's actually reasonably mature as a concept. Military airplanes have it. It's not too attractive to passengers sitting in an aircraft that looks like a wing and flying in it, but that's another concept. We also work a lot on just the air operational efficiency products, and I think George talked about those also, on how to do point-to-point travel, how to avoid weather, how to predict weather. So a lot of that work goes on in India on creating products for airlines to use to replan the flight in flight and to make it easier for the regulators to get that replanned flight path validated and change flights. And all of those are an order of magnitude more than what winglets save the aircraft. So winglets achieve 1 to 2%. This will be an order of, double that, all of these procedures. So these are a few areas where but very excited about where we might be in a few years. I don't want to sound like, hey, this is a prediction, but we need to get away from that, the little wings and the short pipe aircraft concept if we have to get to the next level as a flying fraternity. So what the next aircraft looks like, I don't know, but I'm hoping it won't look like the one that's been there for 60 years.
Absolutely. The tube has served us for long, but I think now we need to look at the other ones. But when my son was young, he used to tell me when a chief engineer came to our house from Airbus, he said, you guys don't know how to design an aircraft, because he said the blended wing is the best. His idea was that you put a big window in front and everybody would like to see everything which is happening, So, okay, he has just finished his aerospace degree. Let's see what he does, It's a great time to enter into aerospace as well, So much things happening at this point in time. So what I would do is that we have about last 8 to 10 minutes. Maybe I'll take some questions from the audience, to see if you have any to the panel as well. So anybody there? Arun? Oh.
My question is, a lot of these futuristic things What is your take on like trying it out in like the metaverse or the virtual world before kind of putting it in the real world? A lot of these are great concepts, but to be able to understand and visualize them, have you already started these things, or do you have any plans?
All right, okay. Anybody wants to? Then you.
Yes, is the answer. I mean, if you go back to the Wright brothers 100 years back, they tried everything in the field. Today, when we start an aircraft from requirements, it's all modeling and simulation. Okay? Otherwise, we would never get to where we are. So every concept, and that's why we mentioned the digital part a lot. Model-based system engineering and the digital thread plays a huge part now. Every new concept, every new technology is modeled, simulated, not just at the technology level, but as it gets simulated and looks okay, it's simulated at the higher level, system of systems level, aircraft level, to see whether it works before any. Otherwise, it becomes very expensive and time consuming. Even additive manufacturing can make parts, but that's not for that. So, yes, everything is done, and we can get much better to cut down that 10-year, 15 billion cost of aircraft development, but it is done. But I'll hand over to some of my colleagues.
You know, metaverse is also going to transform particularly the design, you know, some of these manufacturing, the downstream applications. For example, we have, you know, huge manuals for a pilot or somebody to get trained. You know, you can completely replace this virtual reality, the augmented reality, you know, in manufacturing procedures, the design procedures. So a lot of these digital technologies we are going to, you know, see, which is going to reduce again the cycle time and improve the efficiency of the operations. We are yet to figure out, but you know, aviation industry is one such industry. You want to make sure you introduce technology, you know, at a phase which will be okay from, you know, the adoption point of view, because safety is the most important,
criteria.
you know, parameter.
Yeah,
It's a great question, and you know, I'm out of ideas. It's the next generation that needs to come in and give us these ideas, these far out fun ideas that, you know,
absolutely.
even if 2 of them work out of 20, that's great.
But my take on that is that if you look at aerospace industry is really big on simulations, modeling. You know, they've been right from the beginning. You know, they've been doing that. You know, and this definitely, you know, there'll be a big uptake on that. And metaverse, in my opinion, is a big simulation, right? So from that point of view, yes, there's going to be a lot being done, and a lot is being done today as well. You know, on that.
Yeah. I will add just 2 sentences.
Yeah, please.
See, now it is demanded, right? So traditionally, aerospace development would say a project would run for 10 years, 15 years. That was acceptable earlier. Nowadays, the business model has changed. Unless we think out of box and then adopt new technologies and tools, do it faster, maybe it would be difficult to survive in the market. Exactly. So it is demanded, and then we'll be forced to move to newer techniques and technology.
We'll take at least one more question. You have Arun?
Yeah.
Oh, you have one as well. Okay.
Thanks, Dwarka. And I must compliment you guys for a very enriching discussion. I think aerospace is clearly at a very exciting turning point. My question is that, and great ideas from all of you on sustainability. Obviously, new product development, innovation comes at a great cost. R&D budgets are huge. And then proving it and making it real and actually making it feasible is the big question. So my question is that, you know, the time frames you talked about, 2025 and beyond that, will the product be fit for market from a commercial perspective? And is it something which will have a great level of adoption?
You know, so it might look, you know, all our discussions may look very futuristic. You know, while we are targeting 2050, please remember that there are already around 40,000 aircraft which are flying, and we are talking about how do we reduce, you know, those emissions. So we have to carry forward all the aircraft and all the engines which are already flying and then achieve this goal. So if you look at future, even it is much more dramatic. But coming to your point, you know, the engine that I talked about, we are targeting 2035 as the entry into service with, you know, whether it would have a combination of hybrid electric propulsion, hydrogen combustion, sustainable aviation fuel, and all the other technologies, right? It has to fly, get certified and fly, you know, around 2035 time frame, which means the development work has already started, and, you know, so it's a long journey because we are reinventing the entire aircraft and the propulsion systems.
Yeah, another point I would add, see in aircraft industry mainly, now this is already has been there because cost is a major factor for airlines, the fuel cost increase. So even before this sustainability talk came, in aircraft always the continuous R&D and improvement has been always part of the whole ecosystem. So I take one example that I talked about, GPS based landing system. We have been talking about this maybe 20 years before. Now we have built system that's ready now. It will now really be applied, and then everybody can take advantage of increasing the capacity now that air traffic is increasing. So similarly, I was talking about bandwidth and now data analytics through instrumenting the aircraft systems. So for a long time, there is a need to increase the bandwidth in the aircraft. Maybe now these requirements are coming now. But when we fly, sitting 8 hours, 10 hours, just like that, it's make things really difficult. There was a need to increase the bandwidth. There was a need to take the data out of the aircraft, do analytics on the ground. Even before the aircraft lands, we can do something for the maintenance. So these kind of needs have already driven a lot of technology that is falling in line with the sustainability goal. That's what I was thinking.
I think when they take the sustainability goal itself, they've already looked at all the ones which can contribute, what's happening in all the other areas as well. Time is running out. You have one question there.
Yeah, this is Vishwanathan from NASSCOM. I've attended many aerospace conferences. Very happy to hear all of you completely structuring the conversation to metaverse, data, analytics, digital, etc. Complete transformation. Kudos to all of you. My question is, this industry, if I may use the word, will this industry lead little bit specific specialization, but more generalization? How are you making your companies cool place to work with? There is still an association that's in peak space engineers.
Absolutely.
Yeah, those kind of people are required to come. How are you making a cool place to work with the young engineers coming in?
You want to start?
Yeah, so at Collins, we have a lot of initiatives which is making young engineers feel like cool place. So just to tell, DPLC, Digital Product Lifecycle, is one of the initiative what I can talk. And if you look at that, this initiative is across Collins, right? For example, we roughly have about 2,000 people in the manufacturing. So we have a lot of young engineers coming there and doing the augmented reality and virtual reality, and helping a lot of operators in training them, as well as supporting some of the repair work, etc., right? So that is on one side. Second one is on the MBSE, model-based system engineering, and digital twins, digital threads, and all those things. So we have seen a lot of young engineers who are really fascinated about working on these cutting edge technologies. So the third one is more like flight path optimization, where it's going to be more like a dynamic commands given to the pilot depending on a lot of things. So all these areas you need a lot of AI and ML algorithms. So I think these are all probably the making our industry feel like cool place to that. I agree with you. Some of our qualification and certification activities are probably little stringent compared to some other industry where they will produce next generation chip every 6 months or something like that. But I believe some of these new areas are really attracting talent for us.
You want to jump in? Time is up, so take short one.
Yeah, 25, 30 years before, a new joiner looked for something else. He wanted to work for a company. Our salary was the factor. Today, young engineers look for what technology I will be working on. Right? That's the first question. So at Honeywell, when the new engineers we take, first thing we do, we take the best of the company, best engineers to come and walk them through all the technologies we work on. Really speaking, I tell you, there are incidents happen. We brought aerospace engineers to work on aerospace. They like data analytics and then artificial intelligence. They want to do a support system work because of the technology, right? So that is we enable. So unless we bring technologies into our engineering, we are not going to motivate this. That we consciously do. Second thing, we very systematically enable innovation system. The young engineers like it. So these are two things we do pretty well now to motivate people to join our company and then stay with the company.
Absolutely. You want to?
No, I was just saying, I'm sitting in front of a very cool aerospace savvy crowd with 4 really cool gentlemen here. This should make it cool, look cool to everybody to join this industry.
Hopefully next time it'll be a little bit more diverse rather than the brown middle-aged guys sitting here as well. It'll make it even cooler, but hey, there we are, to do that. Just to quickly summarize, you heard about the lot of technological innovations being done in the aerospace industry, on one side, but then also we talked about the sustainable aviation fuel. In sustainable aviation fuel, we are putting in a lot of bet, and that's where I think there's a lot of focus needed, because across its product life cycle of the sustainable aviation fuel, it can reduce up to 80% in terms of the emission compared to the jet fuel. So that's why it's very important, and there's a lot being done. But of course, the future propulsion systems and others will kick towards the second half. And as Uma was saying, we need to take the actions now, in this decade, in order to take the benefits. But then lots of other things would come in the years to come. But I would say, I think because both of my sons are in aerospace, and I would say that this is a really exciting period to come into aerospace, whether it is aeronautics or space industry, because so many things are getting opened up and so many exciting things. In 20 years' time, as Kalapa was saying, the shape of the aircraft may look completely different, right? Until we come up with the beam-me-up technology from Star Trek. Once we are there, then we may have difficulties with our industry, but otherwise it'll be great. So can you all put your hands together for the wonderful speakers we had here? And
I'd like to
thank you, NASSCOM, for organizing this event as well. Thanks.
I'd like to thank the panelists. Please give them a big round of applause once again. I'd like to thank Srinivasan for moderating that session as well. As a token of our appreciation, we'd like to request Srinivasan to please present a small token of our appreciation to each of our panel members.
Absolutely.
All right, ladies and gentlemen, we're slightly behind schedule, but we shall take a short recess and reconvene here by 11:10. That gives you 10 minutes to network. Not quite sure if coffee and tea is available outside. If it is, please do grab a cup. We'll see you all back in 10 minutes from now.